Thanks for joining us today, everybody.
Great. Thank you so much, Jamie. Hi, everyone. Appreciate the opportunity to present with my esteemed colleague, Ed, over here. And so today we'll be presenting on accessible math. So Ed, if you want to go over, actually, I'm sorry, my head's all over the place. I'm Nasli Kirkjian. My pronouns are she, hers. I'm the SUNY System EIT Accessibility Officer and Coordinator of Disability and Non-Traditional Student Services at SUNY System Administration. Ed?
I'm Ed Beck. I'm an instructional designer at SUNY Oneonta.
I'm in presentation mode now. So our goal for this cohort, we came up with this cohort a few months ago based on some feedback and some people reaching out to Ed, myself, and others about understanding the nuances of math accessibility, with the goal of providing a training for you all today on how to create and deliver accessible math. And so there's a group of us who sought to build knowledge of math accessibility for instructional support staff and disability services practitioners, and bridge the gap with faculty so we could kind of understand what the terminology is, what tools are out there, what the individual students' needs may be, specifically students with disabilities for the purposes of this presentation. And so, our outcome was this presentation. And we've also developed a very brief resource doc that will be living and for you to contribute to later on. And so we'll propose some recommendations for individualized solutions for print disabled students. That does not mean that there are other students with disabilities who may interact with math differently, like speaking into a computer or viewing math in a video, with captions or transcripts and things like that. But we are it's a rabbit hole of a topic, to be quite frank. And so we're trying to give you the information that reaches the largest amount of students that we are familiar with that are enrolled at our colleges and universities. So the cohort members includes myself and Ed, Alexis Clifton, who I see in the chat, hello, Tonka Jokalova from SUNY Canton, and Sumana Silverheels from Buffalo State College. I have to give a special shout out to each of you because, while Ed and I are primarily presenting today, every one of us contributed in different ways. All of our expertise in this space was varied. That's why we came together. We're a group of instructional designers, librarians, disability services, technologists, and more. The spring semester really flew by. We really wanted to include faculty in this group, but we ran out of time. So we're hoping that this is the beginning of ongoing conversations and really welcome your participation in the future. We don't pretend to be experts in this space because it is evolving and growing tremendously. And there's so many nuances from math accessibility to chemistry accessibility, and some gaps in and limitations in what can be made accessible within both of those areas. So we started out with STEM and we kind of just went to math because it was so much. Thank you all, Sumana, Tonka, and Alexis, for gathering some of the content that we put in this presentation today from your fellow faculty and instructors. So our goal today is for you to have a baseline of expected literacy. So you should be able to understand the key concepts related to accessibility and math fundamentals, be knowledgeable about assistive technology and specialized formats, and create accessible math content proactively. Now, I know Jamie's already asked some of you to introduce yourself and where you're from in the chat, but we'd really like to know a little bit more information so we understand a little bit where to focus or what might be best with the flow of this presentation. So if you could kindly put whether or not you're a professor or instructor, an instructional designer, a disability services practitioner, or someone else, that would be really great. I myself came from disability services, and now I'm a student affairs administrator. Ed is from instructional design, but I know he's also taught in K-12, so he's got a lot of insight there. And I see a lot of folks in the chat range from instructional designers, librarians, EIT officer, yay. Let's see here, instructors, wonderful support staff, professor.
I see someone is saying they're a logic professor, and I did a huge project trying to make a logic textbook accessible with all of the notation, specialized notation. The person used logic trees, logic tables, of course. And that's just an example of what we're talking about here is making content accessible that uses specialized notation can be a huge area. And we started to really focus in on math and equations, and we acknowledge there's a whole lot more exploration that needs to keep happening. And so again, we're just looking at this as a start of a conversation because we need to keep having this conversation to get into all those nuances because the topic is enormous.
Yes. So, and for the finance folks on the call, or anyone else really, I mean, we will cover the numerous ways to create accessible math from formulas, but also, through alt text, which we'll define later on. And for those of you who do teach with different, the spectrum of math, how do you create it? I guess, like what language may you use, or authoring tools? Or do you handwrite math? Okay, we got some answers in here. MATLAB, Maple. Okay. Feel free to continue adding those as you, or what are you familiar with? That too. If you're an instructional designer, you have knowledge as well. So please, provide what you've had experiences with. Maybe that's math type. Maybe that's Equatio, written in LaTeX. Okay. All right, we'll move forward. So, big picture, we want to provide the most accessible experiences for our students and campus community members and the public, those with disabilities. And so accessibility is the extent to which information can be perceived by all people with or without the use of assistive technology. It's all about meaningful independence, right? Most of you may be familiar with the Accommodations Framework, where an accommodation is a retrofit or a fixing of a document or a type of course material after the fact. And so that's when a student goes and discloses their disability to the student disability services professionals on campus, and has an interactive process with them to determine what best meets their needs with the learning requirements of your course. And that's all good and fine, but we know there's a ton of students who don't disclose for whatever reason. The largest may be stigma. It could be financial, cultural, or attitudinal barriers to receiving documentation. They could not know that they have a disability. A lot of the executive functioning in your students are developing. At least for traditional age college students, they're beginning to develop, and so they may have a disability later in life that they just didn't realize. And so that's why it's so important for accessible environments to be created proactively to support those who would benefit from accessible design and may also require accommodations. And so that's how we are, prefacing this conversation. And this is incredibly important because, we know there are students with math specifically that have had extreme difficulty with accessing, navigating the content, completing quizzes and tests, reading homework assignments. And the thing is that there are so many options to making math accessible that we don't want our students to be excluded from all of the math requirements or courses that they wish to take just because of how we design or purchase the courseware, right? And so, you know, it's really important that our students have that independence, because that's what we're really here for. And so I'm just going to throw in the chat a video for you to watch on your own time that I think is extremely powerful. It's a student that presented welcoming remarks at Global Accessibility Awareness Day last month, who went into some detail about a particular product and his experiences at one of our colleges with math specifically, and how challenging and also humiliating it was to have someone reading the content out loud to him, when if it was created accessible from the beginning, he would just be able to take that class no problems, right? So for those new to this conversation, there's a lot of ways to access and navigate math through assistive technology. Assistive technologies support students and individuals that may have functional limitations with speaking, typing, writing, hearing, and many other things. And people with different disabilities may require different assistive technologies. Those that are, for example, on this slide here, one of the subcategories of individuals with print disabilities are blind. They may use different software, screen reading software. They may not read Braille. Maybe alt text really is what's best for them. So it's very individualized. I hope that that is one of the biggest takeaways for today. And so on this slide we have here, there's a picture of a refreshable Braille display next to a laptop computer. And a refreshable Braille display is a assistive device that blind individuals use to read what's in, you know, from an electronic device, right? So there's electronic Braille and there's printed Braille. And so, you know, that can be sent to their individual devices. And there's also screen readers, and screen readers read what's presented on the screen out loud. And you know, I think most people associate this technology with individuals who are blind, but there are plenty of other people with disabilities, such as mobile impairments, that benefit from screen reader technologies. And so navigating all our learning management systems and websites and respective documents may be navigated through keyboard controls using these devices. For those with low vision, they might use screen magnification software such as Zoom Text or CCTV, which is a physical device. So if they have a piece of paper, they could bring it to a room that has this technology and it enlarges the font for them. And then, of course, we have students with various learning disabilities, dyscalculia, dysgraphia, dyslexia, and so on. And there are numerous tools available that can read that math in different ways so that they can equitably participate in your course. Now, there are other access considerations we need to explore in the future. Like I said, voice recognition, but for the purposes of today, we will be focusing on print disabilities. So equal access to math can be achieved in various ways. It can be online, and Ed will talk about this later on, how programmatically math can be accessed. It can be accessed through digital text. So through Word documents or PDF documents, if created accessibly, it can be accessed by these various assistive technologies, right? Large print, which is more hard copy, Braille, as I described before, tactile graphics, which is helpful. These are hard copy, lifted, raised print for those who are blind to be able to participate in some more advanced mathematics or chemical notations, for example. And then we won't go into this today, but of course, there's also video and how you write out the captions or audio descriptions and transcripts that relay the math formulas or other information that's mathematical in nature. So to start out, you know, these are the basics of math accessibility fundamentals. Editors need to know how to write accessible math. It needs to be displayed so that individuals can perceive it We'd really like to ensure that you are also happy with how the math looks, while also ensuring that students can literally access it. It needs to be coded so that programs can interact with it. And training is what we're doing today. It's essential, and collaboration between all of us, the IDs, disability services, feedback from our students, and of course, y'all who are teaching to meet individual needs. And so now Ed's going to take over the hard part here.
Y'all stuck with me for a while. So fundamental problem here is math is a language all itself. If you take for a second, just the equations or the things that I've written on this page, if you try to write down 3 plus x over 2, what does that mean? Without extra context, I can't really tell. And what I mean by that is 3 plus x over 2 could be 3 plus the fraction x over 2. It could also be 3 plus x as the numerator of the fraction, denominator 2. It could be, you see how you could break this up in different ways. Math itself just needs a little more context around it and defined rules so it can be read. And it gets even harder, and it's not even just like really advanced math. I mean, area of a circle is what? 5th grade math, 4th grade math? But when we read this equation here at the bottom, is it A equals pi r superscript 2? Or do we know that when you have a capital A, that means area equals pi r squared? You know, what is the context of how we read this math? Down at the bottom, that is something that's, some people might think of a little more advanced. I think the way you would read this, and I got actual math people on this call with me, so if I do it wrong, please don't, stone me. But I think that the way you read this is the summation of x plus 1 from x equals 1 to 5. You read this in a non-linear way. The way a math expert would read this is different than the way it's physically typed on the screen. And so that extra context is really important and really difficult at the same time. We have languages, programmatic rules for how math should be spoken, and there's speech engines for this. And the problem is we're not even getting to this point a lot of times. Like, I'm going to go through in a second and talk to you about what the differences between math speak and clear speak are. We're not even to that level yet, because all the time we're spending all our time just at the surface level. How do we even make math accessible? But that's why we need to keep this conversation going. We need to keep talking with each other. We need to keep figuring this out together, because it is really hard. For a lot of accessibility, sometimes we get like the feeling like, we just gotta, just do this. It's not that hard. Let's do this. Math accessibility is that hard. And we really need to keep the conversation going. And it's got to be more than just, the accessibility services. The IDs have to get involved with it. The students have to get involved with it. We really need to keep the conversation flowing. So here, I promise to tell you the difference between math speak and clear speak. And math speak has like an interesting history. Nemeth, who invented Nemeth Braille, famous blind mathematician who was originally, encouraged not to go into math because just math is just too hard for blind people. He wrote the math speak rules because he needed to be able to tell his secretary how to format his papers, and he would record it, and then she would go and do the typesetting for him. And so the math speak, when you look at it, start fraction, x superscript 5, baseline z, superscript -7. It's really all about conveying exactly how the math should look. When we look at the bottom, the clear speak rules, the fraction with a numerator y to the 5th power. You hear how it's just a little bit more conversational, and it's getting to how someone would actually read that equation. I mean, so much of our conversations about math accessibility don't get to this point. But if we're going to really think about math accessibility as helping, we need to make sure that like the assistive technology expert who's helping that student set up their AT knows the difference between math speak and clear speak and communicate to them. And that's so out of my realm as an instructional designer that's why we need to have that conversation. That's why we built this cohort of people to keep talking, because I'm coming from the ID, from the creation aspect, and Sumana was there as like the AT person, and Nathan was kind of the glue that held us all together. That's what the hope was here. And so, I'm going to go through a couple ways of how to make math accessible. And I just really want to focus on the programmatic way to make math accessible, because these speech engines are important and they can evolve around over time. The joke I told when I made this slide originally is I used to leave my house. And when I used to leave my house, I used to use Siri to tell me where to go. And she's changed over time. She used to say, go right on Bugby Row. And now she says, at the next stoplight, turn right. So that context clues can change and improve over time. And if we keep coding our math to the standard coding, instead of just like writing really detailed alt text, which is not only like time consuming, but also like doesn't give us that ability for it to change and grow over time, I think that's really what we're going to do. So I'm going to keep talking about Mathml, the math markup language. I'm going to really encourage you to look at that, and I'll show you how to do that in some ways, because that gives us room for growth as we go on, because the assistive technology is getting better. The things are getting better, and we want to be able to, the effort that we put in to make our math accessible today, we want to keep getting better tomorrow as the technology grows with us. So again, I just broke down these 4 priorities, and we're going to organize the rest of our time together through this. I'm going to go through how you write it, how it's displayed visually, how it's coded on the back end to make sure that it actually is accessible, and then talk about like that conversation that we need to have. And you know what? Next time I give this presentation, I'm not going to say train. I'm going to say collaborate, because that's what I really mean. That's what I really mean is we just need to keep talking about this. So at the very fundamental level, there's 2 ways to make math accessible. That Mathml solution, or you can sit there and write detailed alt text that gives that same information. And I'm going to keep saying Mathml is the standard for a reason. Let's focus on the Mathml solutions and only use the alt text when we can't do the Mathml. And people who know me know I am an open advocate. I'm an advocate for the use of open educational resources in our classrooms. And so the image to the right is from an open math textbook that was created accessibly. And the reason I chose this example to show to you is one of those 2 is set up programmatically, and one of those is an image with alt text. If you look at the top equation, that A times the quantity B plus C equals A times B plus A times C. That equation was done using Mathml, and that's why I like it. The bottom equation, we couldn't use Mathml. We couldn't use it. Rice University, who created this textbook, couldn't use it. Because a lot of times in math, when we start to annotate the math, or add in arrows, or add in extra things, you can see that to describe this distributive property, they added those extra arrows in. This is actually an image of math with alt text that was manually created and added to the image. And so sometimes it might be necessary to write alt text, but whenever we can, I'm saying use that Mathml markup. So, how are we writing this math? Equation editor in Microsoft Word is a way that we can write this math, or any equation editor, really. There's a lot of equation editors that let us click with our mouse and select the symbols that we need and select the fractions that we need and the kind of things we can do, and we can build it like that. And, people who have loved you and cared about you in the past might have told you things that might not be currently accurate. Like, we used to be told, like, oh, you can't use the equation editor in Microsoft Word. The Microsoft Word equation editor is not accessible. That used to be true. They were not wrong. But since Word 2016, that is not true anymore. If you use equation editor, either in Microsoft Word or Microsoft PowerPoint, it will both display the math for a sighted user, and it also has all that backup contextual information that a screen reader needs to really be able to understand the math. So there are tools like that. There are, the LaTeX language is a very powerful language. It was designed for typesetting math equations. And one of the reasons I really got involved with math accessibility is I was hearing things like, you can't use LaTeX. LaTeX is evil. LaTeX is only a language. It's a way you can write the math coding. The problem with LaTeX is LaTeX all by itself does not add that assistive Mathml that we need for a screen reader to read it. But it doesn't mean we can't use LaTeX. We just need to make sure the tools that we're using also add that Mathml for us. So I will show you some ways, whether it's on the web or other places, that you can, if you are the person that needs to write your math in LaTeX, you can still do that. We just need to add an extra step or use a program that also adds in that Mathml, and we'll get in there. And then the hardest thing, the thing that's really going to trip us up, because we know a lot of people are at the chalkboard, at the whiteboard, handwriting math, creating notes. Some people in my department are using doc cams or overheads. The handwritten math, that's a real challenge, because only digital math can we make accessible. Only digital math. The stuff that's handwritten, we've got a barrier there. That is not to say that there are not programs that can convert handwritten math. The one that always people pop up, Equatio. Equatio is one of these software that's a pay software, but there's also a free kind of introductory license. You can handwrite in Equatio, and it's one of the ones that's honestly quite a little bit better. And it will convert your handwritten math into something that's more accessible. But then you have to then insert it back into a document or insert it into another thing, whether that's in Microsoft Word, whether that is in the, and we have to keep that assistive Mathml. You can see that it's got both it's got both alt text and it's got that descriptive Mathml that we can use with a screen reader. So the original title to this was, assistive math technology, and I changed the title. You probably already have the software you need to create accessible equations on your computer. You probably already have Microsoft Word. That equation editor will make accessible math. If you're working in Blackboard, Canvas, Desire to Learn, each of those has a math type editor in there that it's used in multiple LMSs. And if you use that builder, you can make math that way, and it will be accessible. In addition to being able to use like the click, click, click editor, where you can mouse around, both the MS Word and the math type editors will allow you to write that LaTeX. Some math faculty just find it faster, easier, and it fits in their workflow to write the actual LaTeX. And both of these will let you do that, but then it converts it into both the visual presentation and the assistive Mathml. This is where we need to live. We need to keep evaluating these products to make sure that the faculty members only have to do the work once. They're not going back with, a dustpan trying to sweep up after themselves that might take a long time to remediate. We need to find tools that work within their original workflow that then also make that assistive Mathml. And that's going to vary from campus to campus. Part of the reason why we built this cohort was I was starting to get requests. Will you come in and talk to my math faculty about assistive technology? Will you come in and talk about accessible math with my faculty? And I can't do that for all around SUNY because our technology stacks, what we have available, it's all going to be a little bit different. What we really need to do is understand the fundamentals a little bit better. And we have to understand that the faculty that we're interacting with will have their own preferences. And we need to make this chart that I started building right here and make this a bigger and more robust document that we have lots more solutions because we have too few solutions right now. Because I'm going to keep repeating it. This is hard. It's not easy. It's not just like, oh, buy Equatio and you're done. We're going to need to have various solutions to fit the working flow and the work styles of all of our different editors. I'll give you an example. I threw out there that there was a book that I worked on that was completely written in LaTeX. And I told you earlier, LaTeX by itself will not create an accessible math equation. And so we just need to help it out a little bit. And I have a faculty member on my campus who's going to try to use Pandoc to convert his document, which he wrote 100% in LaTeX, not just like the equations are written in LaTeX and everything else is just in plain type. He wrote his entire book in LaTeX, and we need to figure out a way to just convert that. So we're going to try using a tool called Pandoc to convert what he wrote into an accessible HTML version. We'll keep working on that. I'm collaborating with this faculty member because he's not going to stop using LaTeX. He refers to LaTeX like it's a second parent to him, or third parent. Yeah, it's a third parent to him. LaTeX is very important to his identity as a math professor. He's not going to just switch over and use the Microsoft Word equation editor because I say that that's the best way. So we have to be a little bit flexible. And we have to be aware that there might be multiple ways to achieve the same goal. And the goal is, I'm going to keep saying it over and over again, only two ways to make math accessible. It's got to be that Mathml in the background, or it's got to be alt text. And I don't want to get down the road of writing alt text manually for every single equation, because that will add days onto any creation project. It's got to be programmatic to me if it's going to be scalable across my university. And that's what I'm working on with my faculty. So, I keep talking about Mathml. Mathml is a standard part of HTML5. It has been for a very long time, but there are some problems with Mathml. And the biggest problem is the #1 browsers in the country and in the world don't use it. Mathml works great in Firefox and Safari, but it does not render in Chrome, Edge, Opera. And so what it means is we need to use these helper applications to convert the Mathml, display it one way, but have that helper alt text in another way. And thankfully, there's a really good solution for that. And most of the math you see on the web, whether it's in Wikipedia, whether it's in other things, is going to be using MathJax if it's accessible math. And what that does is it converts the LaTeX that all of our math professionals know and use, and it converts that into either an image, an SVG image, or HTML and CSS that will show up in any monitor. Remember I said Mathml doesn't work in Chrome? With MathJax it does. And it adds that assistive technology. So it's no harder for my faculty member that writes their math in LaTeX. They insert it into a website that's using Mathml, like Blackboard, like Canvas, like Desire to Learn. The program makes it accessible in the background, so they don't need to rewrite everything. That's why MathJax is so important. It's really important that MathJax is free and open source, because that means that it is shared by so many different websites. So this is an example from the MathJax website. If I were to right click on any equation on the MathJax website, I see the accessibility menu pop out. So I see a lot of people here are instructional designers. And you're like, I don't know how to make math accessible. I don't even know what you're doing. Here's one thing you can do to start. And if you go to Lumen Candela, if you go to Lumen OHM, if you go to any decent math software site and you right click on it and it says, and you get that math accessibility menu, you're like, oh my gosh, that's MathJax. If I steer my faculty towards those types of websites that use that stuff, then I have done a small thing to help them understand what they can do, what fits in their workflow, what we can keep doing. And so being able to just identify that is huge. Now, I just have to acknowledge MathJax isn't the only way to make math accessible on the web. Khan Academy created its own math accessibility program. They call it KTEX. And if I click on an equation on Khan Academy and I use that inspect button to see the HTML, if you see that assistive Mathml there, that also is a good indication. But MathJax is used way more than that KTEX. So this is the first thing I look for when I'm evaluating whether a product is using accessible math. Our Blackboard learning management system uses MathJax in a little bit of a different way, but programmatically it converts the math into an image, and then it adds alt text into there. It does it automatically through there. But what we need to know is this is if I'm writing my math equations directly into Blackboard. We don't have something, if I upload a PDF to Blackboard, that will automatically make all of the equations that were part of that PDF accessible. This is if I created a Blackboard quiz, if I created a Blackboard page, if I created an item, I can either write in there in LaTeX or LaTeX, or I can use the math editor in Blackboard and it will be accessible. We'll talk about Microsoft Word in a second, because Microsoft Word, it adds all that important Mathml. But what's really important to know is if you export to a PDF, you lose all that assistive Mathml. So here's my next big takeaway. My next big thing that if you don't learn anything from today's presentation, you gotta know. We're all about universal design and making sure that the main document meets accessibility standards. Math is hard. If you can't make an accessible PDF, which we can, it becomes important to save the source document. Because if I have someone that needs the assistive technology and I made my document using Microsoft Word and I export it as a PDF and I'm giving most of the class the PDF, but that one student or a couple students that use assistive technology need to have the original Microsoft Word document, I have to make sure that I've organized myself so I don't lose that. Because I have a video that I'm going to show you where Sumana went through and the math is able to be read when it's in Microsoft Word. But when we lose that assistive Mathml and it goes to PDF, it becomes a jumbled, jarbled mess, and the screen reader doesn't know what to do with it. So we have to start having those conversations with our faculty members. Hey, keep that source document. Don't lose that. Same thing for my professor who is writing all of his math in LaTeX, just LaTeX, and using the LaTeX conversion engine to convert that to a PDF. That PDF he is making is not accessible. So we have to go back to the source document and export a different version for the people that make, and luckily we can do it with just one command. We can just write a command at the command line and do that conversion, but that's not, he needs to do that extra work. He needs to be prepared to do that extra work. So holding on to the source materials is really important. So I already said all of this. Just get used to keeping those alternative formats. And I will exit out of my presentation and I will share the video that Sumana made for us. I got to give credit there.
Numerator, open parent and
And I will put the volume up as loud as I can, but just know it might be a little bit louder than my my voice. And here we go.
plus 9. Close parent dot open parent 22 minus 4. Close parent end numerator over denominator 8 squared minus 26 end denominator. Numerator evaluate numerator x squared minus 3x plus 2 end numerator over denominator x minus 1 end denominator when x equals minus 2. 2. Perform the indicated operations and simplify colon. 1/3 x plus 1 over 11. Open parent x plus 5. Close blank. 3. Sum from I equals 1 to n of I squared. Alt tab, Alt tab, Math for JAWS demo.pdf, list of 1 item, left parent 10 plus 9, right parent dot left parent 22 minus 4, right parent 82 minus 26. List of 1 item.
Did everybody just hear what he said? He just said 82 minus 26. This is the PDF. And since we've lost all the contextual information, it couldn't tell that that's x squared. It just went to 82 minus 26. It's completely inaccurate, and it would not help a student that needed to get it read. And so the screen reader is going to try to get through all of these down here, but it's going to be inaccurate. It's not going to be right. It's not going to have the contextual information because it lost all of that when we exported. It's the same exact document. So this is us just trying to drive home this message, and I'm going to keep repeating it. Like, keep your source documents because they might work better with the assistive technology than the PDF that we've become used to. We've gotten used to using PDFs as if they're the universal document, and it's just not great for assistive technology. Let's hear the next equation.
Listen. Evaluate italic small x 2 minus 3 italic small x plus 2 italic small x minus 1 when the
it keeps repeating the word italics because it thinks that it's important that the x is in italics, not important that the x is part of the numerator or part of the denominator. It's not giving us the contextual information that we need. This is why we need to code it in a way, because otherwise our students are just going to be lost. And to bring it back to the very beginning, to the video that we shared that said, hey, I couldn't do my math unless my tutor was there reading it for me. I couldn't do the homework without a tutor. I couldn't study without the tutor. I was completely dependent on someone reading there. Yes, we can do accommodations for things, but if we focus on the accessibility from the very beginning, there are technology solutions that we can do to make sure that students can do their work independently on their own schedule, just the same as all of our other students have that right to do the work when they can do it, not based on when a tutor is available. That tutor might be needed for some things. I'm not saying that. Having a tutor that can read on test days might be necessary for accommodation, but if the homework system is inaccessible, if the textbook is inaccessible, if the study materials are inaccessible, those are the things that we work through at our own schedule when we have time. So I'm going to go back to the presentation now, and we'll get back to the train part and start to pop your questions in here. Because we'll have
questions. Well, I said we do have some questions. Do you want me to share?
Yeah, sure. Let's go in here.
So back to the MathJax for a second. Is MathJax built into Blackboard or is it a plugin?
MathJax is built into the default Blackboard. It's already part of Blackboard. You don't need to add a script to make MathJax. I've heard that rumor in the past that you have to add a script to run into Blackboard. MathJax will work in Blackboard by itself. I won't continue on because I'm about to go down a rabbit hole.
Okay. And then can the read aloud feature in Word read math equations that have been created in Word correctly?
Let me go to Sumana for that, because Sumana did that demonstration using the JAWS reader, which is the industry standard screen reader. But let me have her answer that.
Yeah, she's She's been answering the questions in the chat, but Suman, I don't know if you want to unmute yourself or you want me to just read what you said.
I have not tested with the built-in reader because I was testing more for the blind and low vision, and they usually are always using a more sophisticated reader. So that's a good point, and I think that is a good thing that I need to test, and then maybe we can get back to Jessica on that.
Yeah, and I mean, I do know there's another tool out there called the Central Access Reader, which is for print disabled students that don't have visual impairments. And it's a free software for students. It's available on Windows and Microsoft, and it can read accessibly created Word documents out loud. But I too have not tested the read aloud in Word itself. But see, there's never ending work here and in research for further exploration. So,
I'm just gonna throw Pearson under the bus here. We've all heard that there was a violation at several colleges where they were sued by students that deserved to have reasonable access to their math. And because the department was heavily using Pearson's My Math Lab, which only used LaTeX without a helper application to convert that LaTeX into something that would be readable, the students had no access to their homework. And so, Pearson My Math Lab is one of the products that I am like, we have to be awareness of in the ID community to help our math instructors understand. Now, if you look at Pearson My Math Lab today, they have libraries of content that are accessible, and they have entire libraries of content that are still inaccessible. And because these courses are often being built by instructors who are going off and purchasing it by their own or forcing their students to purchase it as part of their textbook costs, we need to have that conversation with them. Why is this important? Oh, do you see that there's two different libraries here? And if you use only this library right here, you're all set and you don't need to do anything extra. You don't need to work any harder. But if you use these libraries over here, those students might not be able to access it. Now, the other part of that Pearson My Math Lab claim is those students asked early in the semester for an accommodation. They were not given accommodation in a reasonable amount of time. They couldn't do their homework. They fell behind. They felt like their university failed them, and that caused them to sue. If they had been given a alternative right then and there at the very beginning, not 5 weeks into the semester, but right then and there, they wouldn't have fallen behind, and maybe they wouldn't have gotten sued.
yeah.
Right?
I mean, it has serious financial implications and academic continuity implications as well. So, yeah, absolutely. And I think what you just said fits real nicely with the slide that we have here on, if you're not creating this yourself, but you're buying or adopting open content, there's all the ways that Ed shared to check accessibility for those that are sighted and able to use the mouse. You can hover over images to see if the alt text is present there. You can also do that by downloading the image and seeing what the description is for that. Right clicking, as he showed on the one OpenStax textbook that had the MathJax accessibility menu there. And using, screen readers or other kinds of assistive technologies manually to test it. So whether you're an instructor or an instructional designer or a disability services professional, anyone can check the accessibility of third-party products and services. So it really is our responsibility as the ones designing these courses and delivering them to check that first and foremost before buying it, and put the responsibility on vendors to make it accessible, because it's really not okay for us to do that for them. We and our students spend a lot of money on these products. And, while Ed mentioned that Pearson and other vendors have been improving the accessibility of some of their newer materials, it's, we need to be aware of what materials are actually accessible and avoid using the ones that are inaccessible, or pick other accessible content that meets the learning objectives of your courses. So we absolutely value choice. It just, a little extra step to check for accessibility goes a long way in prohibiting discrimination from students in our institutions.
I want to just speak for 1 minute about the Blackboard implementation of MathJax, just because so many SUNY schools are on MathJax, and we had that question, like, is MathJax really enabled? And Blackboard uses MathJax, but they do it in kind of a funny way. They take away all the choices that accessibility menu. So we don't see the accessibility menu in Blackboard. They use MathJax on the back end, and they choose what image type that they use, and they also just automatically generate the alt text for you, so you don't actually interact with MathJax on Blackboard. It just does the work in the background, but it does meet minimum standards for accessibility because the alt text will be automatically generated and it is there. It's just kind of a funny implementation. You won't see that accessibility menu like every other MathJax enabled website. But I just wanted to put that out there in case somebody says, well, Ed told me that my Blackboard had MathJax, but when I click on right click, I don't see that accessibility menu. That's why.
I just want to throw out there that I did test that Word document with the immersive reader, the read aloud, and it works just like JAWS was reading it. It's exactly the same way.
Yay! Thank you, Sumana, for doing
Okay.
that on the fly. Really appreciate that.
No problem.
Before I get into this slide, Ed, there's 2 more questions in the chat here.
Yeah.
What is that extra command to convert a fully LaTeX written document into accessible PDF?
So the program we're exploring, and it's still an exploration, that math professor and I are going to work together, but he just needed a month off after this this last year. So we're gonna get back in touch later in June. But we're going to use the PanDoc program, PanDoc. And if you go into their documentation, you can export from PanDoc into a variety of different resources. So we're going to tell PanDoc to convert my original LaTeX into HTML instead of to PDF. And then we're going to tell it and format the math for MathJax. And now, because we know with MathJax, it automatically adds in that assistive Mathml, we're going to have a standalone HTML document with MathJax. And so just like we had the PDF, now we'll have a second alternative format coming from that original document. And, I can't tell you what the command is off the top of my head, but if you go to PanDoc, it's a well-documented program. And if your professors are really doing all of their work in tech or in LaTeX, then they will be comfortable doing commands from the command line, and you can help them understand that. But the 2 things that are important is we're using HTML instead of a PDF, and we're formatting the math from MathJax. And if you do add those 2 extra things to the conversion command, it's going to do a lot better for you.
And also, how are Webassign and Hawks relative to accessibility? Do you know the answers to that, Ed?
I don't know what Hawks is.
Okay. And then you mentioned PanDoc. I thought there is another command that that's how it came across. That's why I'm asking. Hawks is a publisher.
Yeah, so go back to my slide. Go to Hawks, start looking from the very top. If I hover over it, is there alt text? If I right click, are they just using MathJax? If I go into Chrome and use the inspect menu, and I go over to the side where it shows me all of the actual math, is there Mathml there? We have to have a checklist and a thing we can do, an actionable checklist that we can look at to look at the math, because I can't tell you every single vendor. I don't have that that knowledge off the top of my head. We need to start just sharing this knowledge of like, what are the basics of math accessibility so that you can work with your ID or you can work with your campus support team and they can help you answer that question.
I just tested Webassign or whatever that was. And yeah, Webassign, and it wasn't very accessible, but I have to test it with JAWS too. So. But again, there's plenty. I mean, there's so many out there. We can't be testing all of them. So whoever's using whatever needs to test them before they start using it.
So I realize we have like 5 minutes left, and you know, we just we're pretty much done with our presentation. This slide right here just shows you who's enrolled across SUNY, in case that interests you, from 2019 to 2020. Again, this is only students who self-disclose to the disability services offices. The largest category of students with disabilities disclosing are those with neurodevelopmental disabilities, which includes learning disabilities, who may have challenges consuming traditional print. And so that's very important in the context of this conversation. And again, you never know who's going in your class, and they can join at any time. And so sometimes we're very fortunate in that, you know, we have the information well in advance, but you know, we might not. And that's why it's so accessible to create things accessibly from the beginning.
Yeah, and here's why we're talking about know your audience, right? Because, you know, one of the things that we keep throwing out when I go to conferences hearing about math accessibility, one of the tools they keep throwing out is Equatio. Oh, Equatio, it makes it accessible. Well, who would Equatio work for and who would it not work for? If I install the Equatio free plugin browser on my machine, because I'm only going to use stuff that's in the free tier, here's what happens. Every math equation on the page will be highlighted in blue. And if I hover over it, there'll be a little camera button if I say capture math. And if I can find that button and click on it, what it will do is it will read that equation out loud for me. And it will do a very good job of reading it out loud. It reads it. Remember I said math speak, clear speak. Math speak is like, you know, open bracket, 1, 5, close bracket. This will say, you know, the set. So when it does that, it will read it and do it very nicely. That's great for our students that just need it read, but don't have like a visual impairment or a motor impairment, that they can navigate with the mouse and do that. That will be a wonderful tool for them, because they can just get the equations they wanted read out loud for them in a way that helps them. Who will it not work well for? People who rely on a screen reader to read the entire page, because it relies on you being able to use the mouse, find the equation, click on the equation, click on capture. So, you know, as we start to think about, you know, our actual audience, this is the stuff we didn't have the time for yet in that math cohort. This is why we need to keep that conversation going, because there might be tools that are great for some populations, but not great for other populations. And I just want to talk about Equatio, because I often hear like, oh, Equatio solves all your problems. No, it doesn't. You still have to understand alt text or Mathml, and how am I making sure whatever I'm doing is either in one of those two categories.
So, you know, I shared the presentation link to this document, and we started a resources for accessible math doc, and I have a ton more to add to it, but we'd also love you to add to it. You know, we also have different communities of practice that have conversations about EIT accessibility or digital accessibility. And so there's a listserv available. There's a workplace group on Facebook Workplace called the Web Accessibility Group. And, you know, we're totally open to your feedback and suggestions for working together to improve this complex topic. So thank you so much, and really appreciate your time today. And
Thanks,
our emails.
Sorry, Nasli. Go ahead.
Oh, sorry. I was just going to throw my email in the chat, because I don't think we got to our contact slide, but Ed, I don't know if you want to throw in yours too, but
I will. If anybody's not tired of hearing me speak yet.
Sorry for interrupting you, Jamie.
No, it's totally fine. I wanted to thank you all for this work. I know that it's been a challenge trying to become experts at not just math, but the accessibility of math. I understand the struggle. So we really appreciate you guys taking the lead on this. It's now 2 o'clock and we're about to head into our next session. So I'm going to stop the recording.